All right, let's finish this up, and it probably won't take that long. All right. Starting on page 390, they talk about overloading operators. I'm not going to test you at all on overloading operators, but it's something you can do. Okay? Now, you all know this, that if I go and add two numbers together, I don't even put it on the board. If I create, int x equal 10, int y equals 11, int z equals x plus y, you know what happens. So you know how to perform operations on simple variables. You cannot perform operations like that on objects unless you do what's called overload the operator. When you're overloading the operator, you're making it do something it normally could not do. All right, in this case, it's the operator. So what are operators? Plus, minus, multiply, divide, modulo. You can overload those. So the ones that you can overload are shown towards the bottom of page 390. All right? So you can overload all the ones I mentioned to you previously. Notice the ones you cannot overload. You can't overload equals. You can't overload the AND operator or the OR operator, etc. Now, when you overload, you can do stuff that makes you stupid. What I mean is, I could overload the minus operator to make it add two things. That'd be a dumb thing to do, but I could do it. All right, just because you can do something doesn't mean you should do it. So what they talk about on 390, 391, 392, 393, 394, and the top of 395 is how you can do this. All right? They show you examples of how it can be done there. Again, my intention is to not make this any more complex than it already is. So that's all I'm going to say about it. I'm going to just jump right up to page 395. And talk about, you can create, you know what an array is because we had a chapter on that. We've created arrays of strings. If you remember on your test, you created an array of strings, two arrays of strings. One for last names, one for first names, and another one, I guess was another string too, but you could have an array of ints or an array of anything. You can also create an array of objects. All right? In order for that to make sense, think about it this way. Imagine that I'm a programmer and I work for American Family Insurance. I think you'd agree with this, that every day at American Family, they have people that are joining American Family. So they're taking out a homeowner policy or a life or whatever. It doesn't really matter. But every day they're getting new customers. Every day they're losing customers. If you had people who had homeowners insurance and they decide that they don't want a house anymore, they may get rid of their policy. People move and they don't, they leave a company. People die. I mean, stuff like that happens. All right? But the reason I'm telling you this is if you've got a company that's in flux, think about Rankin. That was the joke when I came here. Oh, we hired another Jeffrey Scott because over at the St. Louis campus there was a Jeffrey R. Scott. He has since left. I don't even know what he taught, but he's since left because it was funny when I saw one of the VPs, he came up and talked to me a while back and he goes, "Hey, did you know you're now the only Jeffrey Scott here?" All right? But what I'm saying is things work like that. Things get added, things get removed, things get changed. The reason that I'm telling you that is when we start talking about an array of objects, look at this. This assumes that you only have 7 employees. The problem with that is, what if the company grows? Or what if you decide you don't need 7? All right? So what we are going to talk about, not today, but probably tomorrow, and again, on these handouts that I gave you before, all right, I'm not going to go over this right now, but on these handouts, I also gave you one that's on what are called C-sharp collections. This is short, it's half the size of the other one. But they talk about other things, but one of the things they talk about in here, not only can you have an array, you can have what's called an array list. What's the difference? Arrays are a certain size. Array lists can grow and shrink as your program changes. Does that make sense? So if I put an array list in for my customers at American Family, I could add customers and remove customers whenever I needed to. So we're going to talk about that. All right? Now, when you start to work with these things, again, you can declare an array of anything. So what we will get to is we will create an employee class, much like they did here, but then we will create an array list of employee objects, which I don't think they do here. All right. What's kind of neat, if you look on page 396, using the sort and binary search methods with arrays of objects. Well, guess what? You know what sort is, and you know what binary search is because you did that on your last test. All right. It may appear on one of your next tests. I don't know yet. They haven't been written. On the bottom of this page, so on the bottom of page 396, the author mentions on the very bottom, if it'll let me scroll down there, there's abstract. You've seen that word before. All right? And when I say you've seen it before, you saw it when I showed you the PDF. An abstract class is a class that cannot be instantiated. An abstract method is a method that has no body. Just has like public, void, abstract method, paren, or whatever, with a semicolon. I don't expect that to make a lot of sense to you. But we're going to include abstract classes and abstract methods as we get further and further into this. So you're going to see it. All right. The author also mentions on the bottom of that page, on the bottom of 396, and going up to the top of page 397, that you can have what's called an interface. You're going to do this as well. The cool thing is this abstract class or classes and these interfaces, they work virtually the same way in Java and Android. All right? Now, where it starts to get even heavier, so to speak, come on, is they start talking a little bit about interfaces about halfway down on page 397. The author says you can identify an interface name because it starts with an I. So there's a compare to method, and there is an I comparable interface, if you see this. We're going to use this because we are, not only are we going to do some examples that I've created, we're going to do an example at the end of the chapter as a class, then I will assign a different one to you. All right, there'll be just one problem from Chapter 9 and just one from Chapter 10. They show an example of this comparable thing in figure 940 that's on the bottom of page 398. And again, do I expect you look at this and it totally makes sense? Of course not. But I expect you can look at it and figure out what it does. All right? If I were to do this in a program, if I were to say string S1 equals Jeff, string S2 equals Robert. So if I did something like that, I could compare Jeff with Robert. I think that makes sense to you. All right. If I compare Jeff with Robert, it's going to say R is greater than J. Does that make sense? All right. So what does that mean? And it says here, if this is greater than temp, it's going to return, if these two are the same, then this comparable is going to return 0. If the first one is greater than the second one, it's going to return -1. And if the second one is greater than the first one, it's going to return 1. Why do you care? Because that's the way all string methods work. When you compare strings, what they're showing you here and explaining on page 398 is the way internally strings are handled by any programming language. All right. Now the author goes through and gives you an example on page 399, if you look on the screen here, or in your book if you've got your book. But the author says, this figure shows a program that uses an employee class. All right, let's shrink this down a little bit, which I guess it's not letting me do. But if you look, there's an array. And it says what you have there is an array of 5 employees. Now that should make sense to you. All right. But again, what if that's a small company, what if it grows or what if it shrinks? You can't do that in this program. The way this is written, because you set up an array with 5 employees, if you added 2 employees, you'd have to make a new array of size 7, copy these first 5 to the new array, all right, and then add the other 2. That's ridiculous. So what we're going to do is we're going to use these collections, and we'll talk about that tomorrow to show a better way of doing it than what's shown here on 399. All right? Okay. Then on page 401, the author has the last of the you do it's. Says, in these steps, you create an array of student objects. Same one. So this is the same running example that she's been working with, all right, throughout the entire chapter. And it's 401, 402, and 403. All right. I'd strongly recommend that you at least take a look at. I'm not saying it's going to totally make sense or not. Then the last thing that's covered in here, to my knowledge, on the bottom of page 403, and it goes on to 404 and 405, are destructors. Hopefully this makes sense to you. The opposite of a constructor is a destructor. All right, so construct is called when something comes to life. Destructor is called when something dies, for lack of better words. All right. So as it says there, a destructor contains the actions you require when a class is destroyed. Most often an instance of a class is destroyed when it goes out of scope. You may or may not remember this word, but if I created a class, I don't care what it's called. Let's just say it's called employees. And I say, I'm not going to have these employees anymore. I could say something like employees equal no. That's going to kill it right there. I set it equal to null. Because it doesn't hold anything anymore. Then a destructor will be called. Okay, on the top of page 404, the author says to explicitly declare a constructor, it looks just like a constructor except it has a tilde before it. See that? The little squirrely thing there? All right. What do you typically use a destructor for? The example she gives is foolish. You wouldn't typically write a line that said, hey, this is destroyed. But typically, if something goes out of scope, you might have a file open and you want to close it. You might have a database open and you want to close it. All right, that's the kind of thing you typically do in there. All right. And then finally on 405 to 407, which mercifully ends the chapter, okay, they talk about in here understanding GUI application objects on the bottom of 405, 406, and 407. And the author again is trying to convince you here on the bottom of page 405, says the objects you've been using so far are objects of classes. Every time you create a button, it's a button object, which is part of the button class, etc. All right. It says they encapsulate properties and methods. When you start a Windows Forms application and you drag a button on it, a statement is automatically added to create a button object. And if you say, I've never seen that, that's in one of those designer files that you're not really supposed to touch. All right. But so you see it. If I came in here, all right, I'm going to get rid of this. Okay, this is just, you've seen this, you've worked with this before. But if I come in here and notice under form, I've also got this form designer file right here. I've told you never really should touch, and you shouldn't. All right, there it is. But if I go back into here and I grab a button, let's say, and I drag it out there, there's a button. If I go back to that form designer file, somewhere in there, it's telling me it just created a button object. All right. So everything we have been doing thus far, especially GUI stuff, has been object-oriented, whether you realize it or not. And that's what I believe the author is saying on 405, 406, and 407. All right. All right, 2 more things we're going to do, and then the rest of the period will be yours.